Hello, everybody. We are still discussing the minor losses and the sources of minor losses. And in this video, we're going to discuss the last two cases or sources of minor losses. The first is the bends and branches, which are sometimes called the fittings. And for the fittings, it's just to understand what we mean by fittings. These are just some connections that we put or fit to or connect to the pipes or tubes to do a specific job, either to change the direction of flow. Like here, we can change the direction of flow by 90 degrees in these three cases, or by 45 degrees, or by 180 degrees, to return the flow back to the original direction, or to split the flow. Like here, if you have a T connection, then the fluid is flowing here, and then part of it goes here, and the same for this. Part is going in this direction, or to connect to tubes. We have, let's say we have different tubes and you want to connect them together. And this is one other type. So the cases that we have are very limited. We have only these 8 cases, which I think are the widely most cases. I don't think of any other cases of fittings. But for these cases, we need to discuss them to get more insight about the differences and what we have or what we mean by them. So here we have a fitting that changes. We call it 90 degrees elbow or bend, that it changes the direction of the flow by 90 degrees. We have 3 different types of these 90 degrees elbows. Or bends. The difference is in the between the first and the second is in the angle or the radius of curvature. Here it's smooth bend, and here it's sharp bend. So this is something we discussed before, that as the flow goes through a curved surface, the losses become less, and this is why we have less coefficient than here. Okay. And the reason here, of course, that the fluid will have to go through a sharp change in the direction due to this sharp angle, and this leads to more losses than what we have in the smooth bends. Sometimes to reduce this losses here, we have what we call the bend with vanes. The vanes are just some solid things that are put inside the pipe to direct the flow to go through these or between these bends to change the direction. So this reduces the losses a lot. So you can see the losses here are 0.2, the coefficient is 0.2, and here it's 1.1. So this is one thing we can do to reduce the losses. We have the threaded elbows. It's just elbow that changes the direction by 45 degrees, and the same here for 180 degrees. And I think these are easy to understand. There is one thing that is important here to notice, that we have here 2 different values for this 90 degrees bend. For the return bends, that is the flanged and threaded connections, and it's a good chance to discuss the difference between these two and why the threaded connections always have high losses or lead to higher losses than the flanged connections. The threaded or flanged types is about the way the connection is fitted to the pipe or the tube. So we have 2 options. The threaded connection is simply like the cap of bottles, of the bottle of water or any other thing. It has threads inside, which is kind of helical shape, like lines inside the inner surface of the pipe, like this, and the outer surface of the connection, and it's simply connected by rotation. You rotate the fitting, and it fits inside the tube, and that's it. So this is how it works. And no, we all know that the bottle caps are very, very secure, and they don't release in or leak any liquid if it's properly closed. So it's one of the easiest ways of doing the connections, and it's commonly used at homes. If you think of any natural gas pipe that goes into your home, or the water pipes that go and you connect the tap to the pipe, this is how it's connected. They are all connected by threaded connections. But since the threading or the connection happens inside the pipe, so this part leads to more losses than the other type, because the connection happens inside the pipe, so the surface is not as smooth as before, so this leads to some losses, or some extra losses. Type. This is very nice way of doing the connections, but it's very useful for small dimensions. If you have a small diameter pipe, or a small elbow, or small fitting, this is going to be fine, because it can be easily rotated manually. Okay. And if you want to, even if you want to tighten it well, we have the tools that you can use to do this, whether it's a wrench or whatever. You can do this easily. But for the large pipe, you can think of like the pipe maybe 50 centimeter diameter or 1 meter diameter, like large pipe that are used either for pipelines, or for even for the water supply for cities, or yani big place. Then the pipes are very big, and you cannot rotate the pipe. You cannot hold this pipe and rotate it to do the connection. So there is another option that we use in these cases, which is called the flanged connections. The flanged connections is that you have the pipe, and from the outer surface of the pipe there is this circular disc that's welded to it. So it's part of the pipe itself, and this is it has the holes. This is called the flange, and it has the holes that on the flange outside, and the two sides, or the two pipes that you want to connect, have flanges, and we can put them together, and using bolts and nuts we can connect them together, and this way we can do the connection of the two pipes, and we don't have any issue with rotating the pipes, because you have to just put them, align them well, and put the screws, or the nuts, and the bolts and nuts, and the pipes are connected. So again, this is more commonly used for large pipe diameters, or large diameters. And you can see here there is what's called an insulating gasket. So this is a material that's kind of compressible, that can be or that's put between the two flanges, so that when it's well tightened, this will prevent any leakage of the fluid, whether it's gas or liquid, from inside to outside. Which we have here as an O-ring, which is a rubber ring that is put here to prevent any leakage. So and you can see from here the connection is all happening outside, so the inner part is slightly affected by this connection compared to the threaded connections. That's why the coefficient, the loss coefficient for the flanged connections is always less than that of the threaded connections. Now let's go to the last part, which is about the valves. So the valves there are many types of valves. Inshallah, at the end of the course, I will record some videos about the types of valves and pumps, because this is something we don't cover in this course. So I'm going to keep it till the end, and I'm going to discuss in details the difference between these types of valves and what's the function of each. But for now, let's just take them as just information, that we know that this is a globe valve, so we know that the K is 10. If it's ball valve, the K is 0.05, and so on. So this is as simple as this. We just need to know the type of valve, and then you can pick the proper value of KL. So one last thing here is that I have this table here from another textbook. It contains similar data. It may contain more information, I think, especially for the valves. So I thought it's a good thing to share in case you need it, you can find it. And this is the name of the textbook if you are interested. Yeah. So this is the last thing I want to mention regarding the loss coefficients. Inshallah, next time we are going to solve a couple of problems on the loss coefficients, or how to calculate the minor losses for actual problems or actual cases. And yeah, I'll see you then, inshallah. Goodbye.